Hi dear students, I hope you are sleeping at this time. I am recording this video for recap of what we have discussed in chapter 1 of first unit. After we finished first unit, you already wrote a test in that particular chapter ultrasonics, so you really performed well. My special congratulations to everyone. So as I said, let's have a quick recap for what we discussed in ultrasonics. So we all know ultrasonic is a kind of a wave having frequency more than 20,000 hertz. So basically, sound waves are classified into three categories. The frequency range is below 20 hertz, means they are infrasonic. If the range is between 20 hertz to 20,000 hertz, they are audible range. We, the human being, can hear that range. And obviously, the frequency range above 20,000 hertz, they are ultrasonics. And we also discussed the properties of ultrasonic. They are highly energetic, they can travel longer distances. It will be helpful as a sound signal, and it will act as acoustical grating. When you pass ultrasonic wave onto an object for longer duration, it will produce what a heating effect. These are the properties we discussed. Then we moved on to the production of ultrasonic. So what are the ways we can produce ultrasonic waves? So in our syllabus, two methods are specified: magnetostriction oscillator method and piezoelectric oscillator method. So magnetostriction oscillator method, what we discussed, when you provide an alternating magnetic field to a ferromagnetic rod. The rod, ferromagnetic rod may be iron, nickel, cobalt, something like that. So when you apply a ferromagnetic, alternating magnetic field to a ferromagnetic rod, the rod starts to vibrate longitudinally, and it will emit ultrasonic at a point called resonance. So what is the resonance? The frequency of the oscillatory circuit is equal to frequency of the vibrating rod. So this is what we elaborately discussed in magnetostriction oscillator method. So if you imagine the circuit, just imagine the circuit, dear students. There is a rod, there are two coils wound over the rod, there is a transistor, NPN transistor, and to provide current, there is a battery arrangement where we are providing forward bias to the circuit. So once you give forward bias to the circuit, current will be constituted. This current will go to the oscillatory circuit, which is the combination of L1 and C1, inductance coils L1 and capacitor C1. And in capacitor, you might have already set a value, say about 100 hertz, something like that. So now the current, before you proceed this particular experiment, the rod should be permanently magnetized. So that is the first step. Now the current flows over the coil L1 will change the magnetization of the rod. So the rod starts to vibrate, and there will be production of EMF, because whenever a coil is wounded over a vibrating thing, there will be EMF. So the EMF produced in L1 will go to L2, and it will come to the base of the transistor as a feedback current. So this cycle goes on till resonance is achieved. So what is resonance here? The frequency of the oscillator circuit L1 C1, the oscillator circuit, is equal to frequency of the vibrating rod. So at that particular in a point of time, ultrasonic waves will be emitted at both end of the rod. That's it. This is magnetostriction oscillator method of producing ultrasonic waves. And whereas piezoelectric oscillator, there is an effect called inverse piezoelectric effect. So I elaborately discussed piezoelectric crystal, piezoelectric effect, and inverse piezoelectric effect. So piezoelectric effect, what is piezoelectric effect? There are three main axes in a crystal: optical axis, that is the center axis, and mechanical axis and electrical axis. I'm telling now what is piezoelectric effect. When you supply mechanical force on a mechanical axis with respect to the optic axis, equal and opposite charges, positive and negative, equal and opposite charges are produced at the electrical axis with respect to the optic axis. This is piezoelectric effect. The inverse is the ultra version of piezoelectric effect. When you supply a potential difference on one particular axis, electrical axis, say about, and then the crystal starts to vibrate along mechanical axis, and it will produce ultrasonic resonance as like a magnetostriction effect. So here in this circuit diagram, piezoelectric oscillator circuit, there are two circuits, primary and secondary. There are three coils, L1 and L2, L3. And primary circuit is inductively coupled with secondary circuit. So whatever the current produced in primary will go to the secondary as well. So the charges will come to the plates A and B, and the crystal is placed in between the plates A and B. Once you supply charges to the plates, there is inverse piezoelectric effect. As a result, ultrasonic waves are produced. So this is what the working principle of piezoelectric oscillator. And after discussed two production methods of ultrasonic magnetosection oscillator and piezoelectric oscillator, we moved on to application part. So where ultrasonic waves are used. So we discussed two applications, one in medical field and another in industry. In industry, to test the material to find out whether it is having any defect or not. Okay, so in that case you can use ultrasonics as a scanning tool. And there are different types of scanning. We discussed A scan, amplitude mode scan, B scan, brightness mode scan, and TM scan, time motion scan. A scan, it can reveal one-dimensional information. A single transducer is used, and images will appear as spikes. Based on the height of the reflected pulse, you can tell how much the reflected signal is. And between the distance between two signals, the transmitted pulse and the received pulse, you can tell how far the waves are penetrated through the material. So these things we elaborately discussed. And B scan is brightness mode scan. Images will be appeared as dots. Based on the brightness, you can tell how great the defect is. And third scan is TM scan, time motion scan. It is a combination of both A scan and B scan. Like A scan, the transducer is fixed. Like B scan, the images will appear as dots. If it is a moving object, the images will appear as dots. If it is not, the images will appear as a straight line in your CRO, cathode ray oscilloscope. And finally, we discussed one medical application of ultrasonics, that is sonogram. So sonogram is a kind of medical technique to find out the fetal heart movement. So here the working is the basic principle behind sonogram is Doppler effect, Doppler shift, I would say. The transducer is fixed at the abdominal wall of the mother, and from radio frequency oscillator, the pulses can be driven to the transducer. There ultrasonic waves are produced, and it will be reflected by the fetus, and it will be received at the RFA. RFA means radio frequency amplifier. Then it will be fed into mixer assembly, bandpass filter assembly, and one connection should be given to CRO, another connection should be given to a loudspeaker through an audio frequency amplifier. So you can visualize what is happening inside the abdominal wall of the mother, and you can listen some sounds also. So based on the sound you are listening through the loudspeaker, you can diagnose which part is making that sound. So this is what we have discussed in ultrasonic, and it's the time to move to another chapter of this unit, acoustics. I welcome everyone to that chapter. Thank you.